Today, we're going to talk about solving inequalities again. Only this time we're going to have to use like multiplication and division to solve them, not just addition and subtraction. So we need to think about this a little bit. It's a bit of a thing. All right? When we solve an equation, can I add or subtract the same amount from both sides of the equal sign and it's still equal?
Yes.
That's the rule, right? As long as I add or subtract the same amount from both sides, it's still equal. And the reason for that is, I mean, it's just simple. I mean, look at this. That true? Eh?
Yes.
Okay. And if I subtract the same amount from both sides, is it still true?
Yeah.
And what's going to happen if I add 10 to both sides? Will it still be true? Yeah, it's still true. And so when we're looking at inequalities, so if we had something like x plus 4 is less than or equal to 10, we're subtract 4 from both sides. We do it the same way. And it's still going to be true. And just let me show you this again. So 5 plus 4 is less than or equal to 10. You guys agree? Is that true?
Yeah.
Okay. If I subtract 4 from both sides of the inequality,
Still true.
still true? What if this were a 3? Would that be true? Is 3 plus 4 less than or equal to 9?
No.
If I subtract 4 from both sides, would 3 still be less than or equal to 5?
Yes.
Still true, okay? And if I add the same amount, like if I add 2 to both sides, it's still going to be true, isn't it? Okay? So with the division property and multiplication property, so I have 3x is equal to 21. We just divide both sides by 3, x equals 7, it's all good, right? So what about 3x is less than 21? Yes, I heard. So you're saying, by yes, you're saying
That is
that that's true. That's still going to be true. What if I were to multiply both sides by 2? Would it still be true? You're saying yes?
sure.
Who says yes? Okay. What if I were to divide by -5 on both sides? Would it still be true? Who says yes? Okay, let's look at it. Let's look and see if it really is true. So, Dacelin, give me a number. 3. Fortune, give me a number.
4.
4. Okay. So I'm going to say that that's true. You all okay with this?
Yeah.
Okay. So if I multiply both sides of this thing by 2, is it still true? Okay. What if I multiply both sides by -2? Still true.
No.
What?
No, it's not.
No, it's not. No, it's not.
I've been living in lie my whole life.
So when we multiplied by 2, if I can do this, was it still true?
Yeah.
But when I multiplied by -2, was it true?
No.
It's not true, is it? We'd have to switch our inequality. Let's look at dividing.
I agree.
Here, I'll make this 25. Okay. Let's divide both sides by 5. It work? It worked. Okay. Let's divide both sides by -5.
No.
Doesn't work. It's the other direction now, isn't it? Okay. So here's the deal. When we're solving inequalities, if we have to multiply or divide by a positive number, we don't have to worry about anything. We can multiply or divide by a positive number, solve it, life is good. But if you have to multiply or divide by a negative number, what's going to happen? That's exactly right. You've got to flip the direction of the inequality. Okay, it's going to change the direction of the inequality every time. So you're going to have to solve equations like this. 3x is greater than 9. No problem. We're going to divide both sides by 3. X is greater than 3. We can graph it. You all happy? Everything's good. And then you're going to be given other ones like this. Negative 5 times a is less than or equal to 20. And you're going to divide both sides by negative 5. And what's going to happen to the direction here?
You have to flip.
What about the or equal to bit? If it's equal, will it still be equal?
No.
If it's equal and I divide both sides by negative 5, will it still be equal? Yeah, that's not going to change. The or equal to part, that doesn't change. We can divide by negatives or multiply by negatives. That doesn't change anything. Okay? Just the greater than equal to bit. And here, we don't like add in it doesn't make it suddenly equal or anything like that. Okay? So you just have to change that direction. Take a look at this one. S divided by negative 7 equals greater than or equal to 10. How do I solve that?
You gotta go
What do we do to both sides?
times by negative 7.
Times by negative 7. What's negative 7 divided by negative 7? What?
Positive 1.
Positive 1. So 1 times S, and this is negative 70, but I multiplied by a negative number. So what has to happen?
Flip.
We've got to change the direction. The or equal to part's going to stay the same, but the greater than less than part's going to change if you multiply or divide by a negative number. If you multiply or divide by a positive number, it's not going to change. That's pretty much it. That's the rule you got to remember for today. Turn to page 70. Example 3, right at the top of the page, kind of real lifey. You earn $9.50 per hour at your summer job. Okay, we're doing a story problem. What do we do with that $9.50? We're reading through the problem. What do you do when you come to that? There you go. You write it down. $9.50 per hour. Okay, and you label it so you know what it is. Now, since this is $9.50 per hour, I know that's my wage per hour. So probably not going to label it much more than that. Okay, keep reading. Write and solve an inequality that represents the number of hours you need to work. So what are we looking for here?
Or how much hours do you need to work?
So I'm going to call that H.
Camera.
Hours I need to work. So that's what we're looking for. That's our variable. In order to buy a camera that costs, so $247, that's the cost of the camera. So we need to write and solve an inequality that represents this situation. Ooh. So I go to work for 1 hour. How much money do I have? $9.50. I go to work for 2 hours. How much money do I have? $19. That's right. What if I go to work for 3 hours? Is it $9.50 times 3? Can we just agree on that?
Yeah.
Okay. What if I go to work for 10 hours? $9.50. What if I go to work for H hours? There you go. $9.50 per 1 hour times H hours. We don't know what that is, right? But what do we know about it in comparison to what? Into comparison to that number. How do we want it to compare to this amount? Say it loud. greater than, or preferably greater. Preferably greater than, but at least $247, right? Can we solve that?
Yeah.
What do you guys think? Who says we can solve it? What are we going to do to both sides?
Times both sides by
1
By 1 over 950? Yeah, you're right. I mean, this is a fraction. Now, I was just going to say divide both sides by 950, but you're right. Let's times both sides by 1 hour over $9.50. So we're multiplying by the reciprocal here so that any number times its reciprocal is 1. So 1 times h, right? Greater than or equal to. And I want you to notice something else. See the money here and the money here? This is in the numerator, this one's in the denominator. What happens to the money? They cancel out. They cancel. And what does our answer come out in? Hours. Isn't that what we're looking for? Aren't we looking for how many hours we need to work? So the answer, the number that comes out should be a number of hours, shouldn't it? Okay? So it's 247 over 950. So what does that mean? What are we going to do? What am I going to type on my calculator here? 247 divided by 950. That's right. And I get 26. Now, if I work exactly 26 hours, I'm going to have exactly the amount of money I need for the camera. Correct? But if I work more than it, then I'll have some left over. Now, this is the way real life is. There's hardly ever a case where we would use equal to in a real life problem. Or if we do, we just have the understanding that we get that that's where it would be equal, but we could do more. I mean, it's just the way life is.
I would never spend 247 on a camera.
Wouldn't you?
No.
How much you spend on your phone?
Santa Claus.
I win. Okay. Santa Claus. I don't think you spend $247 on anything because you probably don't have $247. Chapter 2.3. We're going to be doing 1, 2, 4 through 30, the even, 31, 36, oh no, 35, sorry, 35, and 40 through 47. So I'm going to give you tell the rest of the period to work on this, which isn't a whole lot of time. Should be able to get it about halfway done.